It all began in 1977, a year that would quietly change humanity's reach into the cosmos. NASA sent two small travelers, Voyager 1 and Voyager 2, into the unknown. Their mission? To explore the outer worlds, Jupiter, Saturn, Uranus, Neptune, and whatever lay beyond. But what no one expected was that these tiny, aging spacecraft would one day pierce through the invisible edge of the sun's dominion and find something astonishing waiting for them. As the decades rolled on, both Voyagers drifted farther and farther away, their faint signals still whispering across billions of kilometers. Then, the data changed. Somewhere beyond the orbit of Pluto, both probes crossed into a realm no human-made object had ever entered, interstellar space. And at that boundary, they encountered something that sent shockwaves through the scientific community, a sudden, inexplicable surge in temperature, a region burning at nearly 50,000 Kelvin. Imagine that, a frontier of searing plasma not made of fire, but of raw electrified particles at the edge of the sun's power. In this chapter of our journey, we'll uncover what Voyager found at that boundary, what causes this so-called wall of fire, and why this discovery forever changed our picture of where our solar system truly ends. When the Voyagers first set off, their goals were simple: to explore the outer planets and beam back photographs of worlds we had only glimpsed through telescopes. But once that mission was done, they kept going, driven by momentum, curiosity, and a whisper of destiny, toward the outermost region where the sun's breath fades into the galactic winds. As they ventured deeper, their instruments recorded the solar wind, that endless stream of charged particles from our star, growing weaker, thinner, slower. Scientists had long suspected that, at some immense distance, this solar wind would collide with the interstellar medium, the faint mist of gas and dust between the stars, forming a kind of cosmic border called the heliopause. And then, it happened. In 2012, Voyager 1 crossed it. 6 years later, Voyager 2 followed. Both captured the same breathtaking pattern, a sharp spike in plasma temperature, soaring between 30,000 and 50,000 Kelvin. This wasn't a literal wall, of course, but a thin, turbulent veil of compressed plasma, a place where the sun's outward flow meets the galaxy's inward push. Scientists poetically call it a wall of fire. But here's the strange part. Even at tens of thousands of degrees, it couldn't melt or scorch a thing. The plasma there is so incredibly diffuse, fewer than 1 particle per cubic centimeter, that there's no heat to feel, no flames to see. Voyager didn't burn. It simply glided through the storm, untouched, recording the first direct evidence of our solar system's outermost frontier. And what those readings revealed was profound. The edge of our solar system is no silent void. It's a living, shifting boundary sculpted by pressure, plasma, and magnetic fields, the very forces that separate our sun's protective bubble from the galactic ocean beyond. What was once theory had now become fact. The data And so, the Voyagers, tiny, tireless messengers launched nearly half a century ago, became the first to prove that even at the edge of everything we know, the sun still leaves its mark, blazing a boundary between the light of home and the infinite night beyond. There was something else, something subtle yet deeply revealing. When both Voyagers crossed that invisible line into interstellar space, they didn't do it at the same distance. Voyager 1 made the leap at 121 astronomical units from the Sun, while Voyager 2 crossed just slightly closer at 119 AU. That tiny difference might seem trivial, just 2 units across an ocean of space, but it told scientists something profound. The heliosphere isn't a static bubble. It breathes. It expands and contracts like a living organism, pulsing with the rhythm of the sun's own activity. When the sun flares and storms, the heliosphere swells outward. When it falls silent, the heliosphere shrinks back in, retreating toward the planets it protects. And then came an even greater surprise, one that left researchers rethinking decades of theory. Both Voyagers carried instruments to measure magnetic fields. Scientists expected that once they crossed into interstellar space, the direction of the magnetic field would flip dramatically, marking a clear divide between the sun's domain and the galaxy beyond. But when the readings came in, they told a different story. But what really caught everyone's attention was what they found there. Both Voyagers recorded temperatures soaring between 30,000 and 50,000 Kelvin. That's up to 90,000 degrees Fahrenheit. Not a wall in the physical sense, but a searing plasma frontier, a turbulent region so energized it earned the poetic name the Wall of Fire. And yet, the spacecraft were perfectly safe. Out there, the gas is so thin, fewer than 1 particle per cubic centimeter, that even at such extreme temperatures, there's almost no heat transfer. It's like flying through a cosmic furnace made of light instead of flame. The Voyager simply glided through, unharmed, capturing the first ever data from the border between our solar system and the galaxy beyond. Now, nearly half a century after their launch, both probes are still out there, still whispering back data from the dark beyond the sun's reach. Theirs remain the only 2 human-made voices to ever speak from interstellar space. The 2 magnetic fields, solar and galactic, weren't opposites. They were almost parallel, smoothly aligned, as if the 2 cosmic realms were gently blending into one another. It was a quiet revelation. The boundary of the sun's influence wasn't a sharp wall at all, but a gradual transition zone where magnetic lines from the solar system and the galaxy danced together, weaving and sharing energy across a soft, luminous frontier.
This finding reshaped how scientists think about cosmic rays, those high-energy particles born in distant supernovae and scattered across the galaxy. The heliosphere, it turns out, acts like a leaky shield. Most cosmic rays are deflected, pushed away by the sun's magnetic currents, but some still slip through, depending on how active our star is. That invisible exchange has very real consequences. The more cosmic rays that enter, the more radiation fills our solar system, radiation that affects satellites, astronauts, and even the delicate electronics aboard spacecraft heading toward Mars or beyond. The Voyager's data showed that our solar system's edge isn't calm or permanent, it's alive, constantly shifting with the sun's heartbeat and the galaxy's whispering winds. For the first time in history, humanity didn't just observe interstellar space, we entered it. Voyager's crossing wasn't a theoretical milestone, it was a moment of contact, proof that our reach had truly extended beyond the sun's protection. By mapping this borderland, scientists could now model how the heliosphere shields our world and how its constant breathing shapes space weather, knowledge vital for the safety of future explorers venturing into the cosmic deep. But Voyager's legacy doesn't end with our sun. Every star in the galaxy has its own version of this shield, its own astrosphere, shaping and defending the planets that orbit it. The sun's measured boundary now serves as a blueprint for studying how other stars protect their worlds, and perhaps how life might persist beneath their cosmic umbrellas. Even now, across the cold gulf of interstellar space, both Voyagers are still speaking, their faint signals barely whispering home. NASA's engineers carefully ration the spacecraft's remaining power, shutting down non-essential instruments one by one to squeeze out just a few more years of discovery. Each transmission that reaches Earth carries precious data, traces of plasma density, magnetic fields, and cosmic rays, the first direct taste of the galactic ocean beyond our solar system. But one day, likely in the 2030s, the power will fade. Their instruments will go dark, and the voices of Voyager 1 and 2 will fall silent forever. But their journey won't end. They'll keep drifting, two tiny emissaries from Earth, carrying golden records engraved with the sounds and images of our world. Long after our civilization is gone, those records will still glide between the stars, waiting for someone or something to find them. And as new missions prepare to follow their path, such as NASA's proposed interstellar probe, humanity stands ready to push even farther, 3 times beyond Voyager's distance, equipped with sensors that could map the heliosphere's full shape and uncover the secrets of the interstellar medium in greater detail than ever before. Perhaps then we'll learn whether the wall of fire the Voyagers crossed is unique to our sun or a universal frontier shared by every star across the Milky Way. For now, Voyager's message endures, that the edge of our solar system is not silent, not empty, but vibrant and alive. A frontier of motion, plasma, and magnetic breath. And at that distant boundary, where the sun's influence fades into the stars, the Voyagers found not the end of our world, but the pulse of a living star, still echoing across the cosmic sea.